All right, so yesterday, the first half of the video that's posted is Wednesday. We did this warm-up problem, and we went over this homework. So we should all be good there. Today, we're going to do day 3, and day 3 talks about solving actually inequalities. And there's 2 properties that we're going to talk about. First of all, what is an exponential inequality? An exponential inequality are inequalities in which the variable expressions occur as exponents. Log inequalities are inequalities that involve logarithms of variable expressions. To solve exponential and log inequalities algebraically, use the following properties. First one, the exponential property says, okay, if b is a positive real number greater than 1, if you have b to the x is greater than b to the y, if and only if x is greater than y. Okay? And same thing with less than. So if you have b to the x is less than b to the y, then we can say x is less than y. Okay? And then if you have a log, if you have the log base b of x greater than log base b of y, then we can say x is greater than y. And same thing for backwards, okay? You can also solve each logarithm by taking the log of each side or by exponentiating each side. So I'm going to tell you right now, take the log of each side or exponentiating each side. Those are big. You cannot swoop. You cannot swoop in inequalities. Okay, so that's kind of where it's a little bit trickier. Cannot swoop. So as I look at this first one, I know you guys are like, well, I want to swoop, and it might work, but it might not. It depends on which side your inequality or your exponential part's on. It just depends. So you cannot swoop. All right. So what I do for this one, remember, one of our other ways to solve is to take the log of both sides, right? We can, and it says that here, that's one way we can solve. Take the log of each side. So that's what I'm going to do. I'm allowed to do that. I can take the log of each side. So I'm just going to put the log in front of each of these. Log of 3 to the x is less than the log of 20. We're allowed to do that. What are you guys going to do now with this x? Bring it out front. So x times the log of 3 is less than the log of 20. What do I do now to get the x by itself? Divide by the log of 3. And now this is just calculator work. Just remember when you do the log of 20, you have to close that parenthesis, divided by the log of 3. I put equals, it's not equals, it's log x is less than. And what do you guys get when you do that? 2.7 what? 3. Okay, so x is a number less than 2.73. And we could try that. We could test it. Pick a number less than 2.73, like 2.71. Okay, come on. Why is this not working? Why is my board frozen? One second here, guys. Okay, where'd my calculator go? All right, if I do 3 raised to the 2.71, I should get a number less than 20. Is that less than 20? Yep, I'm good. Okay, questions on number 1. Number 2, or part B, is the hardest one up here. Okay? This is where, as you see here, it says we can take the log of both sides or we can exponentiate each side. Okay, this one I can take the log of both sides. This one, I can't take the log of both sides because how do you take the log of a log? Can't. All right, so, and we can't swoop. So here's what you do. What's the base of this logarithm that's hidden? 10. So you are going to raise each of these to the base of your logarithm. So what's the base of my logarithm? 10. So you're going to exponentiate it. It means you're going to do this. I raised them each with a base of 10. Now, before we go any further, if I had log base 3 of x, what would you have raised each side to with a base of? You would say 3 raised to the log base 3 of x is less than or equal to, and then over here I'd have what? 3 squared. So you use whatever that number is what you exponentiate each side with. Okay? Just happened this one was common log base 10. All right, now, the right side is easy. What's 10 squared? 100. So we've got 100 over here. And now, over there was a rule that we learned that we said if you have b raised to the log base b of x, what was it equal to? X. Now, if you don't remember that this is just equal to x, you could think of, I need to know what log raised to the log base 10 of x. I need to know what is that equal to. Well, this is exponential form, so I'm going to swoop it to log form. So I'm going to say log base 10 of what is equal to that. So I'm going to say log base 10 of what equals log base 10 of x. So what's my question mark have to equal? X. So if you don't remember that rule, you could reason through it off to the side. But if you remember the rule, you just say, oh yeah, 10 raised to the log base 10 of x is x. If over here you would have 3 raised to the log base 3 of x, it's still just x. But over here you'd have x is less than or equal to 9. All right, am I done? Yeah, we're done. I could check it. Okay, it says x has to be a number less than or equal to 100. So what is the log of 100? Is that less than or equal to 2? What is the log? Pick a number less than 100. 80? Log of 80? Is that less than 2? I heard log of 1. Is that less than 2? Yeah. Okay. Questions? Oh, however, can't be what? Can't be 0, because if I keep going, pick another number. What's the log of 0? Error. Okay, what's the log of negative 2? Is that a problem? So what do we have to say? It also has to be what? Greater than 0. So x has to be bigger than 0 and less than or equal to 100. Why did I not have to worry about that up here? Why did I not have to worry about that with A? Because the original problem's not a what? Log. Can I raise 3 to a negative power or 3 to 0? What's 3 to 0? Is 1 less than 20? What's 3 to negative 1? 1 over 3. Is that less than 20? Yeah, but when you get here, if you start picking numbers less than or equal to 100, got to be careful. 0 doesn't work. Negatives don't work, so I have to stop there. Okay, are you guys good on B? All right, C. Does anybody think they have this one? This one's the easy one. It was one of the rules, one of the little properties that were up above. Okay, does the logs just go away? X minus 1 is greater than what? God bless you. What do you do now? Add 1. And when you guys add 1, what do you get? X is greater than 3. Okay, do I have to worry about anything? Is every number greater than 3 work? Plug in 3. What do you get? 2. Is that good? Is log of 2 greater than log of... Because it says bigger than 3, so I should really pick 3.1. Okay, so then I get 2.1. Is that greater than log of 2? Yeah. All right, and so on. And you can keep going there. Questions there? All right, we don't have to worry about negatives there. Ooh. Okay. What about this one? Any guesses? Take the log of both sides. Okay, so I have. Now, you could take the log of both sides. No, I guess we could do that. We could do the log. I'll show you both ways. We could take the log of both sides. Greater than the log of 11. What do you do with that quantity? 3x plus 4. Put it out front. Now I'm going to put it in parentheses when I bring it out front because it's all of that times the log of e is greater than the log of. Okay. What could I do now? Divide by what? Oh, I'm trying to solve for x. Log of e. So now I get 3x plus 4 is greater than, well, let's go ahead. We've got the log of 11. Let me clear all this. This is ugly. Log of 11, close your parentheses, divided by log. Now, I'm going to use the e above the division sign because it's not being raised to any power. If you did, you could raise it to the first. And what do you guys get there? 2.40. Okay, now leave that big number up there because we're going to use second answer here. And now what do you guys do? Minus 4. So subtract 4. What do you get when you subtract 4? Negative 1.60. Now what do you do? And I'm going to keep using this answer button. So x is a number greater than, so divide by 3. And what do you guys get? Negative 0.53. And that original problem was exponential, so I don't need to worry about an undefined logarithm. Now, I heard somebody say something else up here. What did somebody else say we could have done? I thought I heard it. Do the what? Thought I heard it. Natural log. Because if I take the natural log of this and the natural log of this, remember that's log base e of e. What's this side give me? 3x plus 4. And now if you do the natural log of 11, guess what you get? 2.39. So do you see how I'm at the same, or actually 2.40. Do you see how I'm at the same spot now? So you could do either side, either one. But I know I like to give you guys something that works all the time. It's exponential. Take the log of both sides. Okay? Questions? All right. You guys have the rest of class time to work on this worksheet.